Hello, and welcome to this Unity tutorial on advanced animation concepts. In this video, we're going to take a look at the animator and the animator parameters. I've gone ahead and created a basic Unity project with two scenes. The first scene, named float integer bool, is going to introduce those first three parameters, and the second scene is going to introduce the trigger parameter. Let's first walk through a basic setup of the scene so that you can compare any configuration that you have to my project. The first thing that I did is with the main camera that is included with the scene, I changed the background color from a blue to a white. Next, I added the CMU logo by, in my hierarchy, I right-clicked, select UI, from here, Image. That'll bring up this image, which I pressed F2 to rename to Logo. I then made sure to drag my image to the image slot in the source image component. Next, I also added a text here for speed, and this was just to give you a visual representation of the animation that is playing. We'll go into this in just a moment. Before we do that though, I would like to visit a few standard settings of the canvas. If you select on the canvas in the hierarchy on the left, take a look at the canvas scaler in the inspector. In the inspector, a property that I changed was the UI scale mode. I changed that from constant pixel size to scale with screen size. The reason for that is, depending on the screen that you are viewing this project with, I would like the elements on my UI to scale appropriately. I chose to go with a 2K resolution. So to do so, I then changed the reference resolution to 1920 by 1080. You'll also need to make sure your Unity is configured for that resolution as well so that you are building your UI components correctly inside your view. If you select on the Game tab, this second option here is a drop-down where you can select a variety of resolutions. I selected the 2K. If you do not have this option available to you, you can select on the plus sign to define a custom resolution and enter these values. Alright, so that is the canvas setup. If you need any help on these, I encourage you to visit some other videos on our channel covering the canvas a little bit more in depth. Let's go ahead and view the project to see what's actually happening. When the project is playing, the default animation will play, which is the CMU logo moving from left to right. You'll notice that the animation speed at the bottom is set to 1. I currently have this configured such that when the user presses 1 or 2, it will change animations. So, for example, if I press 2 on my keyboard, you'll see that it's going to transition to a faster animation. If we take a look at the Animator tab, and if you do not have this open, you can access this via the Window, Animation, Animator. And from here, I have an animator on this object. So before we go into too much detail, I would encourage you to visit the other animation videos that we have on this channel, such as the sprite sheet and timeline animations, to get an idea of how to create a custom animation. For the sake of this video, I've gone ahead and I've created a few animations which automatically added an animator component. So just to slow down a little bit, with the object selected that I want to animate, the logo, I created the animation for it, which added the animator. Every animator has a controller, and the controller defines how the animations play. It's essentially a set of logical conditions that are controlled based on some transition parameters, which is what we're talking about in this video. Let's go back to the animator real quick to view this more in detail. Alright, so a standard animator is going to consist of these components. By default, you will have the entry. The entry is going to be the starting condition of the animation. When you press play for a given object with an animator, it's going to start at the entry and then go to its default animation. You can identify the default animation by the orange color of the animation clip here. Any other animations that have transitions with them, such as this fast movement, you can see we have an arrow going to it and away from it. These are controlled via the parameters that we'll talk about in just a second. But again, this is your default animation, and then we can have n number of additional animations with various transitions between them. You'll have the exit one here, which can be used to control the exit or the end of a life cycle, you could say. It'll be the final state of the animation. We're not going to be covering in this video, but it will be covered in a later video on advanced animation concepts. And then finally, the any state, which we will cover in a little bit when we talk about triggers. Okay, so before we jump into these transitions here, let's quickly take a look at the Parameters tab. The Parameters tab is going to give you the ability to add one of 4 types of parameters. If you click on the plus with the little arrow drop down here, you'll see the 4 types, namely float, integer, bool, and trigger. A float is a fine point decimal number. An integer is a whole number, counting numbers, for example, 0, 1, 2, 3. A boolean is a value that contains true or false. And a trigger is a condition that we can set within code to immediately jump to an animation. For the purposes of this demonstration, we're going to start with the float. So I've gone ahead and created a float here, which is this speed parameter. This speed parameter has a default value of 0. And let me go ahead and create a little bit more space here. So we can side by clicking and dragging the animator component to our project so we can see them play out together. Alright, before we jump back into that, let us see how the parameter speed is actually used. So speed being a floating number, we can use that number to determine when we want a transition between an animation to occur. For example, on entry, the slow movement, which is the C moving back and forth very slowly, will play on a loop by default. If the user presses a number key, then that animation will transition to the next one. So if we take a look at this arrow here, you create these arrows by right-clicking on one of these, and then selecting Make Transition, and then selecting it there. You can use the right mouse button to cancel a pending transition. When you have these set up, you'll want to click on each of them, and here we can take a look at the conditions. The conditions are going to be the conditions that are going to allow this transition to occur. And in this case, we have one parameter, this float parameter that we previously created. So I want to say I would like you to transition from slow movement to fast movement when the speed is greater than 1. So that means when the user presses 2 on the keyboard, which is going to correspond to a speed value of 2, because they press that 2, this will transition from slow movement to fast movement. Okay, how do we get back to slow movement? Well, we'd have to wait for more input from the user. Once the user sets the value of 2, that'll be the value until it is changed. So if the user then presses 1, we want to transition back to slow movement. Taking a look at the conditions here, we can say when speed is less 2, then it will transition back. Let's take a look at what this is going to look like by selecting on the object in the hierarchy, and then let's press play. So here, you'll see that the slow movement is automatically happening. If we click in here and then press 2 on the keyboard, you'll notice an instant transition to the fast movement. If we press 1 on the keyboard now, we'll transition back to the slow movement, and we can flip between these vice versa. Alright, so that's really exciting. Let's take a look at the code that's actually happening behind the scenes to make all of this happen. Alright, so let me maximize this for a moment here, and let's talk about the various components of this script. Now this script, float animation, this script is attached directly to the object that we are interested in. So for example, the logo has the float animation attached here as a script with a reference to the speed text. Alright, going back to the script here, I, oh, excuse me, let me close this error here. One little tip that's very helpful is this tag called serialize field. The serialize field allows a value to show up on the inspector and allow you to maintain its privacy by keeping it private so other scripts cannot access it. So the serialized field, you'll notice we have that tag above the text, speed text, which is what allows that speed text to show up here, because in order for the text speed to be updated, I needed to drag and drop this speed value into here to create that association. Alright, moving back here. The other thing that I have is a reference to the animator. Now this animator is a component, and this component is attached to this object. So for example, the logo, to view the components, we select in the inspector and look through here, we can see the animator. So the animator is a component of this object, and by doing so, we can then get that component off the object. So we say animator equals get component animator. And then in the update function, we can do our check. So we can say if the input.getKeyDown key code alpha1, which is essentially saying if the user presses down 1 on the keyboard, I would like you to perform this. Otherwise, if the user presses down 2, I would like you to do this. Okay, well, in the case that we saw in this example, you saw the user press 2 and that made the speed go a lot faster. But how did that actually work? So when the user pressed 2, this else if of the update triggered because it saw that 2 was pressed. It has a reference to the animator. Because it has a reference to the animator, it's able to communicate information to it. Part of the information that it can communicate is the float parameter. One important thing to note here is that the name of the float parameter, defined in the parentheses here, speed, needs to match the float parameter that is defined in Unity. So for example, here in the parameters, we defined speed. The name of this is case sensitive, and it needs to match exactly what is defined in the script here. So the first parameter of the set float is, well, which float would you like to set? Because we can definitely have multiple floats within there. So we say, hey, I want to set the speed, and then we say, okay, what would you like to set the speed to? Well, in this case, I would like to set it to 1f. The f there is just Unity's way, or C#'s way, of identifying that this is a floating point number. So in this case, if the user presses 1, I would like to set the speed to 1. Otherwise, if they press 2, I would like to set it to 2. And you'll see here we also update the speed text just for some visual confirmation of what is happening. Alright, so as you saw, when that occurs, when the user then presses 1 or 2, with this script attached to the logo object, we can easily transition between these two animations, so that's very exciting. But let's go through the process of defining another parameter here, just so we can go through one together. So what I would like to do now is I'm actually going to delete this speed. It's going to say that this is being used by fast movement and slow movement because it's being used here, but that's okay. We'll go ahead and delete it. Now let's go ahead and create another one. Let's create an integer. And we'll call the integer actually the exact same thing. We'll call it speed. A few important things we'll need to change though. The first thing we'll do is we'll go to the script. And because we're using an integer now, we need to update these functions. So we can say animator.set integer. And then you'll want to make sure to copy this wherever it's being used. You'll notice that it's going to be mad here. And the reason why it's mad is because you're trying to assign a floating point number to an integer, which those types do not convert well in C#. So instead, we're just going to get rid of the f and replace it with just whole numbers. Alright, so we'll go ahead and make sure to Control S to save this script, and let's go back to Unity, which will compile this for us. Before we attempt to run this, though, we do need to remember to check and update our parameters here. So, if we click on this parameter here, we can see the speed, which is what we want to do. But if we look at this drop-down option, we now have a lot of additional variables available to us, or conditions, I should say. So for example, we have greater, less, equals, not equals. Let's try the equals. So we want to transition from slow movement to fast movement when speed is equal to 2. Okay. When do we want to go from fast movement to slow movement? We want to go from fast movement to slow movement when the speed is equal to 1. Okay, that seems to make sense. Let's give it a try and see if I forgot anything. So we'll click play. We can see the animation taking place over here. I will go ahead and select 2 on my keyboard. You can see the transition back here. And if I press 1 on the keyboard, it makes that instant transition. Now, why does it make the instant transition? It's making the instant transition because I have this variable unchecked here, the has exit time. If we want to check those while we're playing this, we can check this for both this one and this one. These are transition arrow parameters. Go ahead and click 2 now. So I did click 2. You saw the speed update, but it's going to complete the whole animation before it transitions to the other one. Depending on what you're doing, it can be nice to have an instant transition, or it can be nice to let the animation play out to its entirety and then transition to the other one. So that discretion is completely left up to you, but you can control that via the has exit time by selecting on the transition here. You can also play with the duration of the transition with these parameters a little bit more in detail. Alright, so that's really exciting. Let's quickly go through the Boolean as well. We'll go ahead and delete this. We know that it's being used, but that's okay. Let's create a Boolean, and we'll just call this flag. So Booleans and flags, they're kind of synonymous terms in programming, where a flag is a condition that can be true or false. It's usually used to indicate something. So in this case, let's go ahead and come back to our script here. Now we did update the name of this, so we need to remember to set the name. So we'll change this to flag. Perfect. It's not an integer anymore, so we will, instead of set integer, let's see, we can set a bool. And we'll want to do that for both of them. And instead of a numeric, we'll need to define the primitive values of true or false. So let's say if the user presses 1, we want to set the flag to false, for example. If the user presses 2, we want to set the flag to true. Okay. Now, I probably wouldn't want to use this. I'm just doing this for an example to see if we can get this Boolean working, but this is what you would use to set a true and false value. Inside of Unity, if we take a look at our transitions here, we now no longer have this flag. So when we look at the transition here, we do not have a condition. We'll have to select the flag, and we'll set that for both of them, and let's think about this. So we want to set the flag to true when we're going to fast movement, and then we'll do false when we're going away from it. Okay, let's see what happens now. So this is unchecked, which means if it's unchecked, it's going to be false. When it's true, you'll see that it has a value of a check. So I'm going to click the 2 now. I clicked the 2, you saw the check come in. So now this is going to move much faster. I'll select the 1, the check goes away, and then it will transition back there. Alright, so that's an example of how to use all 3 of those, the float, integer, bool, and now let's take a look at one of my personal favorites, which is the trigger. The trigger is so useful in a variety of scenarios, especially for developing different types of games. For example, when you need events to happen, right, responsive events such as a character jumping. When the user presses the space bar, you would use a trigger in that instance, such that when you're walking and all of a sudden this event comes along and the user presses space, we need them to immediately jump. That's where triggers really shine in, and you'll be using them as extensively if you continue down the track. Take a look at advanced multimedia design, especially game design. So let's go ahead and open up my next scene here to walk through an example. So there's not a tremendous amount of difference here. One thing I do need to change here is I did create 2 separate animators. What that means is I had an animation, or animator controller, excuse me, for the first 3, the float, the integer, and the boolean. And I also did a control D to duplicate this, and then I called another one trigger. And you'll notice if we take a look at the logo here, this logo controller is using this trigger. So I have this set up here, and let's quickly talk through what it's doing. So we are making use of that any state anymore. So we're saying from any state, I want you to be able to transition to this animation, and then we can define where it goes from there. So for example, in my code, I have it set to if the user presses a certain key, I want to play this scale animation and then transition back to my slow movement. You'll notice the scale parameter here, which we created by setting a trigger, has a little circle, and it's very similar to the Boolean in a sense. Um, we can use the trigger here by selecting on the arrow going from any state to that animation. So in this case, I'm saying I want you to scale when the trigger scale is called upon. So the only condition we have here going from any state to scale is that scale trigger. And then it will just transition normally with no condition back to the slow movement. Let's take a look at the script real quick to see what this looks like. Alright, so the script here is very basic. It just has a reference to the animator on that logo object, and then in the update function we say, if the user presses down the space button, I want you to set a trigger, and that trigger called scale. Now remember that scale does need to match case sensitive to the parameter in this list. Alright, so let's go ahead and play it and see what happens. So I'll go ahead and click the logo just to make sure that we can see what happens over here in the animator. And by doing so, we see the slow movement is going to play over and over. We'll let it loop just one time here, and then we'll go ahead and press space. Then it's going to do that big scale animation and go back. So you'll notice it's going to quickly transition and then head right on back. So that's really all there is to show about the trigger animation. You'll just create a trigger as a parameter. You will set the trigger on the transition between any state and the animation you want to play. And then in your code, you will make sure to set the trigger to the respective one that you created in that parameter list. All right. That is everything that I wanted to show in this first tutorial on advanced animation concepts. In a future tutorial, we are going to cover the animation blend tree, which is going to give us seamless transitions between a bunch of different animations such as idle, walking, running, strafing, that can be used in a variety of scenarios, most popular in your video game courses. I'm really excited to share that with you. If you have any questions, please direct them to your instructor or leave a comment on this video and I'll be happy to get back with you. Thank you so much.